Welcome to Homework Help 6.2. My Screencastify is working. I'm so happy. I have no idea why. I don't know what I did. But that's okay. So, hold on. Yeah, that's fine. So, the first however many, you are just identifying the angles. So it says match the diagrams below with the best name or phrase that describes the angles. Right, so all of your angles are down here. Alternate interior, vertical, complementary. Remember, complementary angles add up to 90 degrees. They form a right angle. That one, I guess I can show you that one. That one, it should be number 5. Is there anything else that's close? Nope. So angles 1 and angle 2, they form a 90-degree angle. So they are complementary. So let's see. What else? Same side interior, linear pair, they form a straight line. Triangle sum theorem, they add up to 180. Yeah, I think you guys will be okay on those. All right, 7 through 10. So let's do, I don't want to do number 7. How about we do number 8? So it says, create an image with side lengths half the size of the given triangle. So we're going to do what we did in class. Use the given, the bell's going off. Can you hear them? Goodness. Use the given pre-image. Okay, I think we're done. Use the given pre-image endpoint C as an endpoint C as the center of dilation to perform the dilation that is indicated below. Okay, so here's our center of dilation, and here's our pre-image. So the first thing you're going to do, and people were doing this different ways. If you're doing it on a computer, you can still measure it on your computer screen. I'm going to put my ruler straight up on the computer. Okay, and so it looks like from it's like 4.5. Wait. Yeah, I'm going to say 4.5. I'm going to double check with my protractor. I have 2 types of measurement. Let me double check with my protractor. Oh, except my protractor only has inches. Never mind. So if you're doing inches, what do I get with my inch? Centimeters are probably the way to go here. Yeah, never mind. I'm going to go centimeters. So I get... Hold on. This is going to take some maneuvering. Retrospect, I probably should have just printed it out. So, oh, actually, that looks like it's exactly 4. Okay, I'm going to go with 4. Woo! So you're measuring from your point to your vertice. So I did, shoot. Which one did I just do? No, I did this one. So actually, let's label our triangle first. So B, A, B, it's a bad triangle. So BC was 4. My text is huge. Oh, it's because I wrote Nick's name. Never mind. So then you just have to do all 3 of them. So C to D. Hold on. Measuring from C to D. I get... Oh, I think they tried to make these nice. I get like either 1. I get like 1.1. I make it be exactly 1. 1.2. 1.1. No. I'm going to say 1.2. That's obnoxious. Okay. But not B to D, C to D. And then C to A. Oh, I used inch. That's why that one was bad. I used inches. Let me go back and use centimeters. C to G. There I go. That's better. Then I get 3. Okay. Use centimeters. I would use centimeters. My bad. And then to A. Using centimeters. 4. C to A. All right. So then half the size. So then you're just going to cut all of those in half. Okay. So you're going to get a smaller triangle. So I'm going to go ahead and actually draw a line to connect C to B. And that was 4 centimeters. So then my new one needs to be 2 centimeters away. Centimeters. This is more annoying than I thought it would be. Let's see. Oh. 1, 2. So like right there. I mean, it should be halfway down the line, right? You're splitting it in half. Okay. C to B. So you're going to do the same thing. I'm going to go ahead and connect them with a line. Oh, not that kind of line. Struggling right now. Okay, this is not my new triangle. We're just figuring out the distance. And then that was 3. Okay, so I'm actually just gonna, you would measure it, but it really, you're gonna find the middle right there. Okay. There's the middle. And then from C to A, this one after I draw on the line, I'll erase it because it's gonna look confusing. So from C to A, so we're gonna have to come over this way, right there. So that was 4, so it should now be 2. Okay. So like right. Should be somewhere around there. Ish. Like gonna be too small of a dot? No, it's fine. Alright. So then you would connect your vertices. So this is B prime, A prime, B prime, and then connect them all together. Boom. Okay. If you want me to I can get rid of the lines if you want, maybe. Yes, I can. Helio triangle. Okay. Let's make the lines a little better. Oh no, you're gonna let me do what I want to do. Let me make my lines. So there. There. And then, oops. Okay, so now you can ignore my blue lines. I did better with red lines. So that's my new little triangle. Hold on. Oh, sorry, I should move my camera back. My bad. Oh, and then I think that's all you have to do for those. Hold on 1 second, guys. It's always good to know if I agree with the book. Do we have about the same drawing? Yes. Good. Hooray. Okay, so that's what you're doing for the rest of them. What a process. And then down here you have to do, you're working backwards, remember? Now you're given the image, so you have to find the center of dilation and the ratio. So we'll do the little house. All right, so to find the center of dilation, you're going to connect your pre-image to your image using all the vertices. So like D to D prime. I don't know how far out I'm going to have to go. Extend the line. E prime to E. Oh, there we go. Okay, so that's probably our intersection point, but let's make sure everything crosses there. C to C, and then extend it. B prime to B, and then extend it. Doop, 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 doop. And then F. Or F prime to F. Those are on the same lines. There we go. So there is your center of rotation. Okay. So you can label that if you want. I'll go ahead and label it. What's not used? We'll put S. So now you have to measure the distance from S to D and S to D prime, right? And that'll tell you your ratio. So try both I would try both inches and centimeters, and whichever one like comes out nicer, just use that. So like if you get 1 inch, then I would use inches. If you get like 1.2, then maybe try centimeters and see if you get a nicer number. Okay, so you're gonna measure the distance from S to D prime. Okay, so it'll be your distance over here, S, D prime. And you're gonna put that over SD. So whatever the distance is. All right, SD prime over SD. Okay, and that will tell you the ratio. And then you can do another side to make sure you're right. So do like maybe the distance from whatever's easiest. S to, do I not have an S to C line? Where's my, oh, there it is. From S to C compared to S to C prime, put them over each other, see what you get. Because you should get the same thing every time. All right, so you're doing the distances. Then the last part of your homework. Based on the given image and pre-image, determine the transformation that occurred. Further, prove that the transformation occurred by showing evidence of some kind. For example, if the transformation was a reflection, show the line of reflection exists, and prove that it is the perpendicular bisector of all segments that connects corresponding points from the image and the image. Jeez, okay. So looking at number 15, did they rotate, reflect, translate, or dilate? All right, well, they're the same size, so they didn't dilate, right? Dilations change size. So it's facing a different, it's oriented differently, so it's more than a translation. Translation is just sliding it around, so the shape would have to stay how it is now. You would just be moving it up or down, left or right. All right, so it's either going to be a reflection or a rotation. So if you have triangle DBC and you rotate it 90 degrees clockwise, okay, we're rotating it in this direction, so that's clockwise. Will you get the same image? So if I were to just rotate this guy 90 degrees clockwise, would I get the same image? Oh, hold on 1 second. Yeah, not bad. All right, we're good to go. So anyways, oh, I was messing around. Don't worry about these. You don't need to do that. I was just trying to figure out different ways to do this one. So 15, actually for all, well, not all of these. For some of these, there are multiple different ways you can get there. So I have my pre-image and I have my image. Okay, one way is for 15, okay, it's going to be a 90 degrees rotation clockwise because we're moving in this direction, so that's clockwise, right? But if you just rotate the shape 90 degrees right now around point C, it's not going to match up perfectly, okay? But if you rotate it around this point, if this is your center of rotation, then you rotate 90 degrees clockwise and you match up. The other way you could look at it, which might make more sense to some of you, I think I like it better, is I rotate this 90 degrees and then I translate it around point C. So I just, other way. I'm here, I'm here. Oh, I don't like being mirrored. So then I do that. There we go. Okay. So I rotate this 90 degrees clockwise and then just translate over one, up one, and then everything would match up. All right, so that's one way to do 15. So then 16, 17, and 18. I'll let you give them a shot. And then if you have questions, please, please, please ask me questions tomorrow. And that's all you got for your homework.